Good afternoon, everybody, and welcome to the first day of this week's Lightweight and Low-Cost Rail Unlocking Innovation event. These events are a collaboration between RIA, the Railway Industry Association, Network Rail, and the UK Rail Research and Innovation Network, UKTram. I'd just like to give some thanks to Richard Jones, my colleague who helped bring this program together before he left RIA to a new challenge. And in fact, you'll hear more from Richard later in the week when he's speaking in his new role. My name's David Clarke. I'm the Technical Director at RIA, and I'm the chair for today's events. Today, we're mostly going to be talking about advances in tram systems. But first, we'll hear from Elaine Clarke from Rail Forum Midlands, who's going to be talking more generally about lightweighting. Then we'll hear from James Hammett of UKTram about new technologies and innovations in light rail. Then we'll hear from Stuart Hillmansen at the University of Birmingham on their AnyRail project. And then we'll have two elevator pitches, which are always really fascinating and a key part of the Unlocking Innovation experience. If you've got any questions you'd like to ask, there'll be a number of chances to ask questions if time permits after each speaker, and at the end of this session we'll have 30 minutes allocated for questions. If you want to ask any questions, use the question dialogue in the control panel, and we will I'll get those questions and I will feed them to the speakers in the question and answer session. If you want, during the Q&A, if you want to speak rather than ask a question, then put up your hand and we'll arrange to unmute you. The plan is to finish about 3:30, and then we're going to actually open up a Zoom call to allow those that want to stay on for a bit more informal networking to do so. So that's the running order. So as you know, up first is Elaine Clarke. Elaine, if you'd like to put your camera on and unmute yourself and be ready. So welcome, Elaine. Thank you for joining us this afternoon. You're going to talk about some work that you've been doing jointly with, or you've been leading on behalf of Rail's Supply Group on the theme of lightweighting, and of course that's major part of our question this week. Lightweight and low-cost railways. So Elaine, over to you.
Thank you very much indeed, David, and thank you very much for the opportunity to talk to everyone this afternoon. For those that don't know me, I'm Elaine Clarke. I'm the Chief Executive of Rail Forum Midlands. We work very closely with RIA. We have a number of members in common, and then we have a number of members that are not members of RIA. But we do work very closely with RIA, and we try and share ideas, etc., as it makes sense to do so for the benefit of the industry. What I'm going to talk to you about this afternoon is a project that is part of the rail sector deal, and it's really just an opportunity to give you an update on what we've been doing. So this is where I find out if I can move the slides. Hopefully, there we go. So the background to this particular piece of work is that we have been asked to lead a specific piece of work as part of the sector deal called the Midlands Pilots. And there are two specific pilots. Just to give you the background, the first is called SME Growth Through Collaboration, and that is based on identifying and providing specific challenges or opportunities for SMEs to respond to meet the needs of clients. So it's actually identifying real opportunities that clients have got and providing SMEs with the opportunity to work collaboratively to respond to those. And we've currently got two specific projects, if you like, ongoing in that arena. First on lightweighting, which is what today's about, and we've got a second one that's just started on decarbonising freight. The second pilot is about skills, and it's basically about identifying opportunities to increase the number of apprentices in the industry, particularly in SMEs, through some sort of shared arrangement, and by developing a more additionally identifying opportunities for the industry to work more collaboratively on the schools engagement activity across the Midlands region. I'm not going to talk about any of that today. I've just put that in for background so that you understand and have a bit of an appreciation of how this all fits together. So I'm going to focus on the lightweighting specific project that we've got ongoing. So we launched our project back in the summer, and the challenge on lightweighting was set by 4 specific clients working together: Bombardier, Hitachi, Porterbrook and Siemens. So we have 3 OEMs and a Roscoe. When we set the challenge, we specifically asked if there were any boundaries, any areas of the vehicle that the clients weren't interested in. And basically they said, no, anything goes. We're really interested in any ideas that the SME community might have to remove weight from the vehicle. That can be interiors, exteriors, traction systems, anything. So there's no boundaries. It was literally a open house for ideas. We launched the collaboration, or the challenge, on the 21st of July. And we had just short of 100 companies join that launch event, which was amazing. And that includes a variety of companies from across the industry, not just our members, but also RIA members and other organisations as well. And we had 6 initial submissions, followed by a further 7 submissions. And the approach and process that we've adopted, we've tried to keep this as simple and easy as possible for everybody. So it was a very simple initial submission form that went through to all the clients, and they selected whether they wanted to hear more about the idea at a Dragon's Den style pitch session. And all the submissions have actually gone forward to the Dragon's Den. So we've had 13 Dragon's Den pitches, where all the clients have been present to listen, to hear the ideas in more detail, and then to ask some questions. The one thing that's different about this Dragon's Den to perhaps what you're used to on TV is that there isn't an offer at the end of the Dragon's Den from one client where they outbid each other. It's very much open to all the clients to take forward as many of the ideas as they wish. But all those ideas have been pitched during 2 Dragon's Den sessions, one in October and one in November. And in total, we had 31 SMEs get involved in those 13 different submissions. So 31 SMEs working collaboratively together with 5 universities and 2 research centres. So I think it's a really good testament to the level of interest out there in the SME community if they are given the opportunity to understand what the challenges are that the clients have got and respond to them. So all the clients can take forward any or all of the ideas for more detailed discussions, and of the potential 52 potential opportunities, so that's 13 pitches times the 4 clients. So of the 52 separate possible opportunities, 35 are being taken forward as we speak for further discussion. So that's a pretty decent, I think, initial success rate. But we've clearly got some way to go before they result in real orders and actual new products actually on our trains. But that's where we've got to at the moment. So it's a good start, and we've learnt a lot along the way. So just to finish off, I think we will continue to support those 13 different collaborative ideas, but we've learned some really important lessons, and we've identified some really important issues, I think, along the way so far. So we will be doing an interim report for the Rail Supply Group Council in January. Whilst the whole point of these challenges is to give companies real opportunities to get their innovations and their products onto the vehicles, onto the railway. I think it's really vital that we also learn the bigger lessons, because otherwise the pilot just becomes it's just another initiative, and we want it to be more than that. So it's really important that we really flag up the key issues that are coming out of those challenges, the key barriers, some of which we've known probably for many years, some of which we've raised before, but where we're now really identifying real evidence to justify those issues, as it were. So, for example, things like how do we protect SMEs' intellectual property and their ideas, and we've got all sorts of stuff going on, from full non-disclosure agreements to a slightly more lightweight, pardon the pun, lighter version of a simpler document, access to funding, who makes decisions, even issues around who within clients makes the decisions about supporting funding. And that's really important for UK innovation going forward. The inevitable one about cost versus value, so initial cost versus whole life cost, etc. So there's a whole number of really important issues coming out of the process so far that we can provide evidence for and feed back into the wider industry in terms of, what can we now do next to start to break through some of those bigger barriers for the benefit of our SMEs. So as I say, we'll continue to monitor progress. We'll continue to provide support to those 13 collaborative partnerships that have been identified so far, and hopefully I'll get the chance to update you in the future about how it's all going. I think that's probably enough from me, David. It's a quick run through, but hopefully just giving people a little bit of an idea of what's happening, and that we are doing work in the background, as it were, to try and support our SMEs to get their innovations onto the railway.
Thanks very much, Elaine. I mean, it seems really valuable exercise on two levels: in the actual practical projects that you're taking through, but also the learning that you've just been describing. I'd like to come back to that, but I've got some questions that have come through. The first one is the one that was forefront in my mind, and Malcolm DeBell is asking it. Are you able to give any examples of the kind of things that you've seen coming through? I mean, without giving away any sort of commercial confidentiality, which is a tricky bit, I guess.
Yeah, it is a difficult one, because I thought we'll do a list out some of the ideas, and we can't really do that because of the confidentiality. I think we've had quite a few ideas around interiors. We've had a few ideas for around more sort of the heavier systems on a train. Let's leave it at that. And then we've had perhaps just the odd one or two that are a bit more conceptual in terms of design and use of advanced materials. So it's quite a broad range across several aspects of the vehicle.
So in the Dragon's Den, did you have the OEMs sort of sat in the panel as the Dragons, and you had a pitch from one of the companies coming in individually? So from an IP, for confidentiality point of view, all of the OEMs heard what was said, but none of the competitors heard what was said. Is that how it worked? That's
exactly right. So yeah, we've kept to try and obviously protect our SMEs, IP, etc., and their partnerships. We kept each one separate. The OEMs all sat together, which is perhaps a little bit unusual in our industry. But they did all sort of join the Dragon's Den together, and they asked their collective questions together. So they all heard each other's questions and all heard the answers to each other's questions. So that in itself was quite, I think, quite innovative, because we don't always get our OEMs talking to each other in that way. And that, touch wood, that seems to have worked pretty well so far. We did have quite a dialogue around the whole issue of intellectual property, NDAs, etc. One or two of the OEMs wanted to have an NDA. They felt it would be best for them and for the SMEs, whereas a couple have signed what we've developed, which we've called a fair treatment charter. So it's not a legal document in the same way as an NDA. It's meant to be a signal of intent and a signal that we will all treat each other sensibly and fairly. And we felt that was a sort of a nice halfway house for the purposes of the exercise. So that's something that we've developed as part of this exercise.
So I think you might have just answered one of the other questions, which was, who is the NDA between? So if I understand correctly, it's where an individual OEM chose to partner with an individual SME, and they did a bilateral NDA, whereas you have your more general fair treatment charter when it's a more open approach. Yeah,
the NDA will actually be between the OEM and the SME collaborative partners. So if there's 3 SMEs in the partnership, it's more than two-way. It'll be all 3 of the SMEs.
Okay, I see. So, any thoughts on what you would hope the typical development time to be for the ideas? That's a challenging question, isn't it?
It is, and it's actually an interesting one, because we said, you know, when we said there's no holes barred, there's no sort of boundary to the scope. That included, it could be something very conceptual, or it could be, you know, it could be something that's ready to go. So I think it really is as long as a piece of string. There are probably some ideas that are quicker to market and some that are longer route to market. And without trying to go off the subject, if I take our decarbonising freight project, which is only recently launched, we've had exactly that discussion in that arena as well. And one of the questions from the SMEs was, you know, what technology readiness level are you looking for? Are you looking for something that's ready to go to market? And the view from the clients there was any. You know, if you've got an idea, let's look at the idea. But if you've got something that you've already developed for a different industry that we can plug in tomorrow, we're equally interested in that. So I suspect it's probably, you know, going back to lightweighting, thinking about the ideas there. It's probably, you know, it's not going to be next week or next month. It's going to be several months to a year before I think we see those things coming through, if they do indeed, touch wood, come through, just because of, you know, regulatory approvals and all the usual.
As you said earlier, it's really good to see the OEMs working together in this way. It'll be interesting to see if in the medium term, as a group of private companies, they're able to be any more or less agile than the government, arm's length government bodies that are often involved in this space. I've got a couple of questions, so a couple of observations really. So Simon Nowitzki of Huddersfield, thanks you very much for supporting this, and your colleagues for supporting this process. Found it very helpful, and they're still following up the links established, so that sounds like a real vote of confidence. Looking to the future, there's two sort of related questions. How do SMEs take part in upcoming projects of this nature? And do you have to be a paid-up member of Rail Forum to access these opportunities?
So the easy answer to the second one is no, you absolutely do not. Our work for the rail sector deal is very much for the industry. So we have tried to publicise any upcoming similar challenges through all the trade associations that we think are relevant, including not just rail specific ones. So we have absolutely advertised them through RIA, and I know that RIA have sent them out on their mail shots, etc. But we've also advertised through other trade associations like Make UK, as an example, if it's a manufacturing related sort of challenge. So you don't have to be a member of any trade association. Best thing to do is just keep your ear to the ground through these sorts of events and through the various websites. And the first part of the question, David, just remind me.
It was how does an SME get involved in a future tranche? You know, if you're doing this, how would I get involved as an SME?
So I think it's basically, as I just said, to keep an eye on the website, our website, RIA's website, because I'm sure RIA will put them out for us, and the various mail shots. We've also, both the challenges that we've launched to date, we've advertised in the trade press. So again, if you're not a member of a trade association, you get to hear about it that way. So we are trying to make sure that we are publicising opportunities as they come up.
Excellent. So there's two last quick questions which are related. They're both about the target you're aiming for, lightweighting. And one is, you know, do you have a target? And the other is, do you have a view as to what the value of the saving is? Because I think there's some work done a while ago by RSSB, which got a surprisingly low value to saving a kilogram of weight. So, you know, do you have views as to, other than it's a good thing to do, do you have aspirations target-wise?
We did talk about a target in the early days with one of the OEMs, because the original idea for the project came from one of the OEMs, and we talked about a 20%, 30% target. We talked about setting a really ambitious target, because it's a little bit like the moonshot concept. If you set a really ambitious target, you might get somewhere close to it. And the reason we didn't in the end was because we thought that to try and do that across everything generically was really difficult. To do that across, say, a HVAC system compared to, I don't know, a seat, for example, it would be difficult to, you're comparing apples and oranges. So we sort of steered away from that. And similarly, we've steered away from the cost aspect because we're trying to look at the sort of the whole value. And one of the key things that has come into the Dragon's Den quite strongly in terms of some of the questions that have been asked has been around sustainability. So I think there's an angle around recyclability of materials, using lightweight materials. There's an angle around sustainability, and there's also an angle around cost of production and generation of carbon, or rather not generating carbon. So I think it's a wider discussion, and I think it's really early days for that, David, and I think that's something that I'm sure you, us, RSSB and others will be having those discussions over the next year or so, because I think some of those things will come more to the fore as we move forward. So that's not trying to chicken out of answering the question. It's just a genuine.
No, I think you're right, though. It's good. There's a whole set of questions about what will a specification for a future train look like in the net zero carbon. So Elaine, that's been absolutely fantastic. You can tell by the number of questions that excited a lot of interest. I know you can't stay for questions later, so thank you very much for dealing with those questions so comprehensively.
No problem. If other people have got questions, by all means, come back to me through David or directly. I'm more than happy to try and help. But thank you very much indeed for the opportunity, and enjoy the rest of the afternoon. Thank
you very much, Elaine, and enjoy your event later on this afternoon. So thank you very much for your support. Bye. And all the best. Cheers.
Bye.
Okay, thanks, Elaine. So next up, James Hammett, Managing Director, UKTram. Welcome. So James, you're going to tell us about the latest innovations in light rail. So we're moving from lightweighting into light rail proper. So James, take it away, please.
Thank you, David. Good afternoon, everyone. Great to be here. For those of you who hopefully you've all heard of UKTram before, we're the trade body for light rail in the British Isles. We cover everything from lobbying government for more money for light rail to day-to-day issues on operating systems, right the way through to innovation. Got 5 key pillars that we're delivering in our 3-year business plan. One of those areas is innovation. So I'm very pleased to be talking about that today. Spent far too much of the last 8-9 months dealing with securing more money to make sure we could keep running in light rail due to the pandemic. We successfully helped secure about £250 million to make sure that we can keep light rail running, keep providing services for everyone. So really glad to come and talk about innovation. Something that's always close to my heart. So it's going to be a bit of a whistle-stop tour about some of the things we've been working on over the last few years, what's new and current, and what's coming next. So without further ado, I'll just run through some of the areas that we have been looking at within innovation. Safety and welfare, that's of passengers, that's of staff, it's everyone involved. Our customer service, all the aspects of engineering, talking rolling stock, you're talking about maintenance, you're talking about building, infrastructure, the whole lot. Operationally, things that can help systems run more efficiently, better, easier to monitor. Power and energy, a big topic, and design and asset logging systems. There's a lot of information out there. We can keep track of what's out there and how it's lasting and everything that goes on with it. It should make the industry a lot more efficient as we move forward. And a biggie, which we all get used to, new cars that comes with new technologies, driver assistance systems. Well, they're coming in light rail as well. I'm sure they are heavy rail too, but there's a lot more stuff, I think, pushing forward in light rail because we do have quite a bit of flexibility and adaptability in our field. So I'll roll us on to some of the current innovations. I mentioned safety. One of the big points here is safety, risk management in the UK light rail sector. I mean, anyone in the business, obviously, Sanderland's not too distant memory. So something that's changed our industry hugely over the last few years. And through that, we've actually set up the Light Rail Safety Standards Board, which is we're the parent organisation for that body. But obviously, they are working very closely with industry. and have developed an industry risk model with all our members and with Atkins, so we can actually quantify what levels we're at within the industry, and we can identify the highest risks. And we're talking not just your day-to-day, this is the low frequency, high consequence ones like Sandilands. It doesn't happen very often, but when it does, it's catastrophic. So been doing a lot of work on that, utilising modelling and analysing what that's putting out, and how we best then interpret that into something that we developed within UKTram, which is a tram accident and incident database. That's now being run by LRSSB. We developed it, they're now implementing it with all our members. And that is basically a live, up-to-date, day-to-day, any incident, near miss that happens on a system gets put into this database. So again, we can run reports, we can run analysis. Each system can look at their own one, and then we can look at it as globally as an industry. So, it's an innovation in how we're trying to improve the safety within light rail. And with all of that, that's tied into RM3, which is something that ORR are very keen for us to take on. Most of you have probably heard of it, risk maturity model. And that is being tied in with Bowtie XP, which at the top of my slide here, you can see there is a model of the Bowtie safety method of how you actually mitigate what happens with any incident. The incident's in the middle, and you put your barriers on one side and then the causal effects on the other, and you can work out how you can best stop something becoming a real problem at the end. So it's a really unique way of doing things. It's been used in petrochemical industry, it's been used in a lot of other industries, but it's the first time it's been brought into light rail on a major scale. So this is something we're really looking to ramp up. As well as all of that we're doing, the individual safety aspects, alertness and well-being of staff. We all know kind of the leading factors towards Sandilands. We've actually been trialling systems that detect drivers' alertness, whether they're actually paying attention to the track in front, what's going on around them, whether they're falling asleep, whether they've been distracted or whatever. There are several systems out that are available, and we actually did a program with Ian Rowe Associates where we took all of those that were on the market and we analysed them down to those that we felt could perform, that could actually bring a benefit to light rail. And we ended up testing 4 different systems, and that was actually done rather than live on a tram where you've got to take a tram out of service, fit it on. It was actually done in a tram simulator, which is shown down in the bottom right hand corner there. So we were able to actually fatigue drivers. We made people drive all night long, so they would be getting tired and sleepy, and videoed it so we could actually see what was happening to them to make sure that these systems were picking up driver alertness and what sort of level that they were picking up on. So that's using 2 lots of technology in one. The other thing that we've been looking at recently, which has only really been used in Midland Metro, but is something that we think can go a lot further, is the heat mapping of tram loadings. Something that we've always wanted to look at doing is loading. So a bit like with a tube, train, you know which door to go to when it's a slightly less busy, but also what are the busy times of day. We get it when we go on Google and see when you're planning your journeys. But actually it's been really utilised for trying to spread the loads of people with social distancing in place across the tram systems during the COVID pandemic. So that's still being utilised today and is working to really good effect in Birmingham. They've been able to keep their passenger numbers a lot higher than most other systems because they've been able to help push people towards quieter times of day and tell them when it's best for them to travel. And then, of course, goes without saying, and it's a bit of a giveaway with the picture there, the catenary-free operation in Birmingham. While catenary-free has been around for a while, it's the first one in the UK, and it's something that we were very keen and very much involved with. We had a load of funding that we were able to put towards that project back when it was kicked off. So really great to see that taking shape and moving forward. A couple of the other things that we were looking on, rolling on from what I said about with the simulator. Well, we're using simulators a lot more for driver development, driver competency checking, and also control room. We've gone from just being able to drive your tram along the track at your various systems to actually control room. If you've ever been in a railway or tramway control centre, a lot of the time it's just same old, but when something happens, you don't get to practice when something happens. When an incident happens, you've got to respond. There's no way to practice the scenarios. but actually no, there is. We've actually built this control room simulator where you can actually put in all these different scenarios of power outages, block blinds, all the rest of it. So you can actually get the controllers to practice this offline, so you're not disrupting the service, and you can actually look at how you can maybe improve it. So if you do ones, people have always done some, recovered from the situation in a certain way. We're actually looking at how we can possibly do that better, and we've put in how that affects passengers. You might look at the service, turn a tram round short and say, well, if we send this tram back that way, gets the service back on, but actually what you've done, you've left 200 people at a tram stop there with no tram coming your way. So it's just making sure we can tie all of that up and improve efficiencies on the systems. Probably one of the biggest things that most of you guys would have already been aware of was our low impact light rail competition that we did with Innovate UK, and that they were the ones that have bore fruit to things like the track slab installation, PCAT's track slab that's down at Long Marston alongside M-Track's H-beam and Costain's channel system. Now, these are all ones that have been put in to demonstrate, but actually all of these are now being developed on a stage further. We've put straight track in the ground, and I think you're hearing from some of these people later on in this week about how we're looking at doing switches and crossings and sharp radius curves in the same sort of track form. So it's not just on the straight bits that we can use these new technologies, it's the whole system that we're looking to work at getting put in place. From the same project, we also had the OLE, lightweight composite OLE, which, having heard Elaine's presentation earlier on about lightweighting stuff, all this very much does, using composite poles and clips and lightweight, not only quicker to install and easy to re-put up overhead and all the rest of it, takes a lot of the weight out of the sky as well. And again, that's the demonstration of that is down at Long Marston, where we've got our test site. From the same competition, we had driven out with a smart drive, more energy efficient trams, and that looked at the optimum drive, a bit like your optimum drive in your car, but we can plan the routes. We know where all the tram routes go, so they feed it in the optimal drive and then actually work that back out from the data to get the drivers to switch off, coast, brake later, brake earlier, whatever's best to get the most optimum drive on that line. And it showed between an 11 and 17% saving on energy, which when you know what the energy bills are like in light rail, that is quite a saving. So a really good piece of work that came out from that. And then we had the ones on rail. We had the Weld Restore, which obviously with grooved rail that's already in situ, it's not an easy change. It's not easy to change stuff out. So can we look at ways of prolonging the life? And that's what the Weld Restore was looking at doing. And also the limits of wear was studied as well. How far, no one's really gone, people use different tolerances. How far can we wear the rail before actually it starts becoming, doesn't work at its optimal, and you're risking your derailments, bad ride, whatever it may be. So what are the actual limits? Where are they defined? Something that's actually now built into a much bigger piece of work within the industry. Can't talk about innovation without mentioning, I know some people will say, oh, well, they've had it for years over in Europe and internationally, but we've not had it in the UK before. Tram train. Obviously, to prove tram train can work, works very well. Sheffield to Rotherham, very successful, and I have to say, to get 100% passenger satisfaction when they were, when they did the passenger survey earlier on this year is fantastic. Shows that it can work. There's a lot of interest in more tram train going forward. But the real thing that they've done with the tram train pilot was build the tram train learning hub. And that actually means that all the information, all the learning that was done in that pilot project is now there for everyone else to use. So unlike when we do so many of these innovation things, you come along and everyone starts trying to reinvent the wheel because they want to do it, but they haven't learned from what other people have done. So a real good piece of work has been done there. And while we're talking about rolling stock, tram train, and a bit of a drive out of Sandylands, but one of the new innovations coming along now is Resi Glaze, which is about passenger safety. It's by far UK with Warwick University, being supported by Coventry Council. So all varying fields, many different aspects of what's being done in light rail. And what's the latest stuff on the block? Well, we've talked about Resi Glaze, that's already on the way. Go back, I know maybe saying it's very safety focused, but something else that's safety focused is the DISC project, which is actually driver innovation safety challenge. And what's been born out of this is the Focus Plus device. This was developed by, a project was actually started by Edinburgh Trams with support from Scottish Government with some initial funding. That funding has since ceased, unfortunately, but the project carries on, something we're supporting within UKTram, Transport for Edinburgh, and a lot of the industry partners are already involved. And what Focus Plus is, it's a wearable device, just like a watch, it's about the size of a watch, and it monitors a lot of parameters in the driver, your oxygen saturation levels, your attentiveness, heart rate, loads of different things. So it will actually feed back to control and the device itself, a red, amber, green. So obviously, if you're all good, fit, healthy, alert, there's a green light, no problem. If there's something starting to show that may be of concern, you might get an amber warning. Maybe you're getting fatigued, maybe you're starting to become unwell, maybe you're coming down with COVID symptoms. It's been tuned to pick up a lot of the symptoms with COVID. And then if there's a red, it's a very much you need to get the driver off, they need to go and seek medical advice. It's not a diagnostic, it won't tell you what is wrong, that's not the design of it, but it's there to be a forewarning system. There's a lot of interest. We're looking to roll out the pilots across the industry in these coming months. They're already being trialled up in Edinburgh, and we're looking to get more out across the rest of the tram systems into 2021. Again, along the whole lines of safety, tram speed control. Obviously, Croydon have put in their Belize-based PPOS system that stops tram overspeeding going around any of the high-risk tight curves or any areas that need to be particularly slow. But that is done through Tag and Belize-based systems. And then we've been doing trials with the SIMU system, which is fitted on Metro Tenerife, and that uses GPS and odometer readings. So actually the tram tracks where it is on the track, and actually it can report whether it's within the speed limit across the whole of the network. So it's not just in the places that have been allocated. You can look at it across the whole network. You can put geofencing on certain areas. You can install and take off temporary speed restrictions, and it'll monitor the driver as well as activating the brake system or warning system if the tram should overspeed. So again, I know Heavy Rail have got their ERTMS and loads of things on there, but tram has always been very reliant on the driver. We're line of sight. So this is all stuff to help aid the driver and help improve safety, without losing the flexibility of operation that you get with light rail. And while we're talking safety, not on tram, but this is working around tramways, anyone who's had to work around a tramway before now will be aware that you need to have a permit to work, if it be the window cleaner, trying to come along New Street and clean windows, needs to get near the overhead line, you need a permit to work. A lot of paperwork involved in that. Well, actually, we're now putting this all on an app-based system. It's going to be available, so people, all they have to do is download the app and they can log their details in, they can get the permit to work, they can pay for the permit, and it's all done online. So you lose all the paperwork, but all of that information is stored in a big cloud and can be processed and can be accessed. So it should actually make things easier, quicker, and more user-friendly as we move forward. Okay, we've mentioned driver assistance systems. Well, it's not just speed control, it's obstacle detection, it's alerts, it's whether things have moved. We've had people before now, overhead's been pulled down because driver hadn't noticed it actually sagged, there'd been a failure, the overhead's come down slightly lower, they've not seen it. There's all sorts of devices being trialled, especially in Europe, on detecting whether there's stuff blocking the track, whether stuff's come down too low, wear limits and everything. So that's all a lot of things that have been put on as we go forward. Talking of hazards, we've also developed a hazard perception system. This is with Ian Rowe Associates, to see how drivers are aware of hazards on the system. So a bit like, I remember doing my DVLA theory test when I learned to drive a car, and you got played a DVD and you had to pick out all the things that were a hazard. Well, this is a much more sophisticated version where you are going along a tram line and different scenarios come out, and it checks the driver's actually aware of what's happening, potential issues that are coming out. Have you seen the cyclist? Have you seen someone opening a car door? Or the driver's actually driving a little too, yeah, it's all right, it'll be okay. Or the driver's too risk averse, and sort of slowing down and too nervous. So not only will it check driver competencies, it will help with seeing if someone's suitable to be a driver when systems are recruiting. So That's it really there in terms of driver assistance systems, hazard awareness. But we start talking about virtual worlds. We talk about, you know, I actually managed to fix a tram the other day, but all in virtual reality. Fault came up on the vehicle, your VR headset on, and you actually walk through and reset the panels, find where the fault is on a door, and actually fix it through virtual reality. So you're not having to practice it. You know, I've spent years as a rolling stock engineer myself, trying to fix things go along. Well, you get to practice it. You can practice and practice and practice and look for these faults instead of waiting for something to come up and then actually find it. So looking very much more at virtual life and how things go. And you can see this down here with virtual drivers and virtual maintenance as we go along. Other innovations that we're looking at, new developing, because I know I've seen David appear on my screen now, so it obviously means that I'm getting towards the end of my time slot, is that we're looking at things from in-cab signalling, get away with all the line side equipment. You know, we're looking at much more technology, stuff's getting beamed in cab. Why can't we do that with signalling? All the way down to new technologies. We've talked about Birmingham's catenary-free operation, it's hydrogen power, there's solar PV charging, and there's energy storage on the vehicles. All stuff that's still to come that we're looking at, that's developing in the back, and some of them getting a lot closer than others as we move along. So, last thing, what are we looking for? What's next? Well, actually, anything, bring it to us. You know, things that will help advise passengers on loading, like the hotspots we've talked about, more training, digitization, through to cleaning systems for COVID-19, yeah, antibacterial grab rails, anything that can make light rail better, more efficient as we drive things forward. Very much a whistle-stop tour, as you've probably seen. There is a lot going on in the industry, and that is only a fraction of what we do within UKTram. So I will pause for breath and hand back to David to see if there is time for a question or two before you kick me off the screen.
Thanks very much, James. It's clear there is an awful lot going on. We have got a number of questions, but I'm going to move on to the next speaker and ask you to come back and deal with the questions in the panel session later. Once we've heard from the speakers, as I said earlier, we'll have a panel session. So James, thank you very much for a very comprehensive and, as you say, whistle-stop tour of all the exciting things that are going on in the tram world. So yeah, if you can come back for the panel, that will be great.
Fantastic.
Yeah, okay, so I'm going to hand over now to Stuart Hillmansen. So Stuart from the University of Birmingham, reader in railway traction systems. Stuart, you're going to tell us about your AnyRail project and with a couple of case studies. So over to you.
Thank you very much, David, and also thanks, James, because you just briefly introduced this project in the midst of the masses of stuff you were telling us about. So thank you very much for that. This is going to be a bit of a story about AnyRail, which is a spin-out company that's come out of the University of Birmingham, and I'll tell you a bit about the history of it and why we've done it and what kicked us off and where we got to. So it's all about optimization of train traction systems and energy reduction. So as a spin-out company that's come from the University of Birmingham, I'm a reader in traction systems here, so I'm interested in how trains move and how they stop and the best way of moving them through a system. I also spend my time looking at hydrogen traction systems on the main line, and we've done a lot of work in that area recently. But our interests include light rail, and I think there's a lot of renewed interest in light rail, and it's an extremely efficient way of moving people around cities very, very well, and lots of people enjoy traveling by light rail, so we've got an interest in it in terms of making it more efficient and saving costs for the industry. The AnyRail project came out of an SBRI call, and this was sponsored by UKTram, and we got two stages of funding to take this forward, and we also worked with Ricardo Rail in terms of our delivery partner to implement it, which I'll tell you about shortly on Edinburgh Trams. It's focused on predominantly light rail systems and metros, but there's no reason why it can't work for the main line either. The physics is still the same, and the optimization algorithms are the same. I should just say, following on from a comment from James, is the light rail industry is incredibly agile, and they're actually able to implement things really quickly. So from our experience, doing innovation with light rail in mind is really quite exciting, because you can go from research project to implementation in a comparatively short space of time. And the railways we've worked with have got just do it attitude and get things done and implemented and deployed across their operation very, very quickly. So we focus on the light rail market, and we're trying to save energy basically, and we've demonstrated that you can save up to 17% compared to typical sort of journeys on light rail systems. So we'll tell you the story about how we do that. We offer a number of things within AnyRail. Primarily, it's about driver strategy optimization, so finding the best way to drive between two stations, and also sort of the visualization of that. So we have algorithms which can work out the best strategy, and then also monitor how drivers are driving towards that optimized strategy to give feedback to help them improve their driving system. And importantly, particularly for trains and trams which are doing regeneration, you can save a lot by optimizing your timetable, and that's quite simple really. You just have to synchronize braking trains with accelerating trains, because the overall traction demand for a railway system or tram system is actually quite peaky, and if you optimize the traction with the traction power with the braking power, you can actually save quite a lot of energy with that way. So we also have that feature within AnyRail. The first thing we do if we're working with a railway system is do a lot of background calculations before we do anything on the railway. And we use a software package to do this, where we implement the route information about the tram or train, and then run a set of optimization algorithms, which then works out the best places to apply traction power, the best places to coast, and best places to brake. And we can work out energy consumption. We can also include some information about the power network as well, if we've got that available, and put in information about where the substations are and so on. So it's a full model, physics model of the railway system that we use to work out the optimized strategy. And this is quite user friendly, and we can supply this to the railway so they can play around with it. So if something changes in the railway, like a new stop's introduced or a slightly different speed limit is introduced somewhere, then you can rerun this and come up with new optimization algorithms based on new information. One thing that's increasingly common is automatic train operating systems, particularly for metros, and we can run our optimization algorithms, which will either optimize for automatic train operation or human driving systems. So for a human, we put a constraint into the optimization so that they don't have to do lots of different actions. So it makes it much easier for a human to drive to that, whereas an ATO kind of doesn't care what instructions you give it, and you can give it far more instructions and have a better optimization than you would necessarily with a human driving. So we can tackle both, and we have had a look at both, particularly on a metro railway system in China, in Beijing, where we explored ATO and human driving systems. Once we've done that optimization, we want to try and implement it, and we do that with a low-cost driver advisory system that we've developed, and we're developing this further now. It's fairly simple. We don't want to give the drivers too much information. They just need to know what they need to know. So on the bottom left picture shows you an example of a user interface, which just says what mode the vehicle should be, target speed, and a countdown clock saying when the mode should change. So in 25 seconds time, we enter coasting mode, for example. So it's a very simple system to optimize and provide information to the driver. So this is one way of doing the implementation, but in fact another way is just to use very simple old technology, which is coasting boards, and that's the ultimate way we've implemented it in Edinburgh, is to introduce coasting boards at the optimized places. We demonstrate savings of up to 17% on Edinburgh, and we delivered this training particularly with the partnership with Ricardo Rail to disseminate it and train all of their driver trainers, and we trained the trainers, and then they trained the rest of the cohort and the rest of the driver fleets. Another thing we can do is look at post-process the results really, and see how well drivers go. So this is OTMR data that then goes through some post-processing, and here we see basically speed versus distance on the top graph, and then speed versus time on the bottom, and then the red lines. The top one actually shows the AW category, which is the passenger loading, which is also stored in the OTMR, which might be relevant to the operator to see when you get peak loading. Interestingly, hope you can see it, there's some green dots on these lines. So green is the green dots on the top figure show when the vehicle is coasting. And interestingly here, if you look at that first journey from position 0 to just beyond 1 kilometre, the tram actually accelerates in about 350 meters, and then the rest of the journey, which is 700 meters, it uses no power at all. So one of the things that we do is explain to the drivers just how long the vehicle can coast, because many of them are familiar with coasting, but they don't quite believe quite how far you can coast. So 700 meters on a tram system is really a long way, and you often can't see the station stop. So we instruct the drivers to reduce power to 0, and they often gave us a kind of confused look, saying surely we're not going to get there. But in fact, trams are actually extremely efficient and aerodynamic, so they don't really slow down very much, and you can see we only kind of lose about 10 kilometers an hour in that first part of coasting before braking is applied. So yeah, it's really quite remarkable how far tram will go once you've got it up to speed and you reduce the power to 0, and that's the whole principle behind this this energy saving. I mentioned we can also do timetable optimization, and this is simple in principle, but quite complicated to implement. And basically the principle is that you want a train arriving at a station, some station, and then a station nearby for a train to be leaving it. And we can do this and adjust timetable slightly with optimization to try and maximize the number of times when you get this overlapping behavior. And this is a very messy graph showing a train trajectory thing with a standard one and then an optimized timetable. That's fairly complex, but can achieve energy savings. So I'm going to look a little bit more detail in the final sort of few minutes. This Edinburgh Trams. It's a fairly simple tram system with quite a lot of off-street running at highish speed, roughly 14 kilometres long, 750 volt overhead. And now we have our system implemented on the whole network, all the off-street part of the network. So all the trams are driving according to our optimized profile. This was us testing it out a number of years ago. We borrowed a tram and ran it overnight and did all the prototyping of the system, and just to show that it would work quite well. And we got good initial results from that. Here are some of the initial results, and you can see the blue line is the standard drive cycle, and then we did the sort of orange and yellow lines are the optimized one. And you'll be able to see in the central sections where we've got the higher speed, we actually don't need to travel as fast, so to hit such a high speed. So we generally use a harder acceleration, a lot more coasting, and then similar braking style. So we don't really affect the braking at the end, but we often have to brake at a lower speed because you've already coasted down to a lower speed before you apply the brakes. And this doesn't have an impact on the timetable either. So we can, because we have a higher acceleration rate, you stop in the you have an overall sectional running time which is equivalent to what you've had previously. There's some cumulative graphs of the total traction energy, and you can see the blue line is the initial one, and then the two lower lines showing the energy saving. So here we get that sort of 11 to 17% energy saving on this section, which, as James said, you know, we're talking like millions of pounds worth of bills on some light rail schemes. So that does translate into quite a significant financial saving that you get. These are some results from actually in-service testing. So we took a driver who was experienced with this driving strategy, and we basically jumped on some trams, a number of different trams, and drove according to the new strategy and compared it with the standard one, and we got quite consistent results in terms of the driver being able to follow the driving strategy and decent amount of saving each time. So we showed it was repeatable, and ultimately it's very, very simple to implement, because the principle is harder acceleration until the point where you start coasting, then you do a long and comfortable coasting period, and then gentle braking to a stand at the end. So it's not particularly complicated. We tried it out in China as well, as part of a similar project on a metro system, and got similar results on the Beijing metro system here. So here we see our researchers instructing Chinese drivers to drive on the Beijing metro with a similar optimization applied. And then this is a similar graph to the others, where you've got that red line showing the optimized driving strategy, and we get a similar kind of saving of 15 to 20% over the route. So that's the end of my presentation. Thank you very much. If you want to find any more, you can Google any rail or the University of Birmingham and contact me, and we can tell you a little bit more about it. But ultimately, it's a very simple idea that we've implemented, and it doesn't cost a lot and saves quite a lot of money. So thank you very much for your attention.
Thank you, Stuart. And you recovered some time as well, so thank you for that too. So energy recovery and time recovery, what's not to like? So if you don't mind, we'll hold the questions till the panel session, and if we move on to our first of our pictures. So first of all, we're going to hear from Maxime Stagnitto. Hi, Maxime, and you're going to talk to us about your train simulator tool, yeah? So 5 minutes, can I hand over to you, Maxime? Are you muted? We can't hear you yet. Say something.
Are you able to hear me now?
We can hear you now. Okay, we'll start the clock again. Off you go. Okay, over to you, Maxime.
Hey. All good. Okay, brilliant. Sorry about that, everyone. So good afternoon. My name is Maxime Stagnitto. I am currently in charge of developing the train software within MottMacDonald, and I'm also a traction power engineer. So today I will briefly present to you the recent developments in Train, which is MottMacDonald's in-house traction power modeling tool. There we go. So I will quickly, briefly explain what Train is about, and talk to you about two of our main innovation and new developments that we've implemented this year, which is the multi-conductor engine and an onboard energy storage feature. So first of all, what is Train? So Train is a rail and transit system performance simulator, which is optimized for traction power modeling. That's applicable both to AC and DC systems, and has been used on many different projects across light rail, heavy rail, freight, and many different applications. It's been in development for over 20 years and is currently sold as a software license or as a service by our traction power team in MottMacDonald. So how Train works in short, effectively the user will provide some input data, which is composed of rolling stock information, infrastructure, including the rails and the traction power system and any operating conditions. And during the simulation, which is being run by the user, the mechanical and operational parts of the system are going to be conversing with each other, and they're going to model the vehicle movements The mechanical demand is in turn converted to a power demand, and the electrical solver conducts a load flow analysis, which solves your electrical network. This is repeated at each time step over the simulation length, and results are generated as an output, which provides results in terms of infrastructure, so anything related to traction power results, but also operational results and train performance results. So here are some of the main questions that Train can help answer. First of all, is the design robust enough? So this tool can provide crucial design information such as equipment sizing, which can help inform your design when you're trying to create a new traction power system. It also helps with the verification of the suitability of a proposed design. Second question could be, can the network support additional load? So by modeling an existing infrastructure and an increased service frequency or a new fleet, Train can pinpoint vulnerable elements of your network which need upgrading and effectively help you optimize your upgrades to avoid over-engineering. Next is, can the network be more efficient? So we've talked a lot about this during the previous presentations. There's been some very interesting presentations. So Train is able to model regenerative braking as well as wayside and onboard supercapacitors to help create some energy savings and effectively reduce your consumption overall. And finally, what about obstacles to electrification? So this is very topical in the context of the decarbonization of railways and enabling electrification. Train can model discontinuous supply systems, and which can be supported by batteries to bridge any gaps in electrification. So the first of the two developments I want to talk about is our new multi-conductor engine. So it's called Plus MCE, so multi-conductor engine, and effectively it sits as an alternative to our regular electrical solver. So the regular electrical solver is based on a lumped impedance system, which doesn't have the same amount of detail as our new system. So the new system is more complex, but also more detailed. So just a quick overview of this tool. It relies on the principles of multi-conductor transmission line modeling, which allow increased accuracy of when you're modeling AC systems mainly. In short, it considers the spatial proximity of parallel conductors and how they interact with each other. This is in terms of mutual impedance, for instance. This can be very useful to model systems such as HS2 or large AC systems. However, it's not only for AC systems, it's also applicable to DC. The new electrical solver has increased flexibility, which makes it an ideal tool to model bespoke AC or DC power systems with complex circuit topologies, which is one of the main points really. It also helps identify induced voltages at specific frequencies on victim cables which may be running along the track, such as telecom or signaling cables, which may be vulnerable to DC systems. We also have an additional capability for resonance study, which allows the user to map the system impedance over a range of frequencies, thus analyzing the stability of the system. And we are looking at future developments which will help us make more detailed studies and specialized studies, as well as focusing on EMC applications. So the second feature I want to talk about is our onboard energy storage system. And it's becoming more and more relevant in the context of light rail systems. The feature sits as an interface between our existing electrical solver and the Train solver, and effectively acts as an interface between both. It allows us to model two types of onboard energy storage systems. So we've got batteries, which are usually high energy density and allow for longer run times off wire, and also supercapacitors, which make use of the high power to efficiently capture dynamic braking energy. We've implemented some flexibility into the system, into this feature, to allow many different control options to manage power, current, or the state of charge of the OESS. This includes examples such as using the dynamic dwell time for charging, which allows the train to stand enough time to be able to recharge fully before going into an off-wire section, or for example, the charging point current control, which allows us to increase the charging rate when the train is stabling. There's also an opportunity to mix both systems together into one train and run simulations to get both the advantages of energy recuperation and of running off-wire. So this was a very quick overview over our new features. So thank you very much for your attention. And if you have any questions, please feel free to contact us. We have an email and a website for you to contact us. Thank you.
Thank you very much, Maxime. And you're going to be available for the Q&A panel after the next session, aren't you? So we can pick up any questions then. So thank you very much. Now, if I can invite David Bailey to put his camera on. Good afternoon, David. David is the UK Operations Director of Steconfer Rail, and he's going to talk to us about the Msheireb Downtown Doha Tram project, the MDD project. So David, over to you.
Good afternoon, everyone, and thank you, David, for that introduction, and many thanks to RIA for affording us this opportunity of making what will be a very brief presentation. Just a little bit about Steconfer. Steconfer Rail UK is a very young company. We were only registered in 2018, but we're a full subsidiary of the parent company, which is a privately owned Portuguese rail system installation contractor, which specializes in light rail and ballastless track systems. We have a very close relationship with TIG-M, which is a Californian company specializing in the development, engineering, and supply of low-weight, low-cost tram systems without the need for any line-side traction power supply at all. And you may be aware that TIG-M were recent 3 times winners at the 2020 Global Light Rail Awards. So I'm having a bit of trouble advancing the slides.
So David, click on the slide and then try advancing it.
Yeah,
there you go.
Here we go. This is a very quick video that I'd like to show you from Msheireb. And again, it's looking to misbehave, I'm afraid. So this is a 2-kilometer system where Steconfer installed all of the embedded rail for TIG-M. The system opened late 2019. I hope you can see it's a real-life working example of a truly low-weight, low-cost system. And the technology is definitely not running with me today, I'm afraid. A key feature of the TIG-M system is virtual coupling. It allows multiple vehicles to be joined electronically. There's a space of about 1 meter between each tram. And as you can see, it gives you scalable tram size. Trams, the whole consist can be changed to reflect demands during peak and off-peak time. It reduces excessive driver costs because it only needs the one driver to control multiple units, and completely eliminates dead heading seats. Some brief facts and figures and advantages. The problem with line side power, whether it's third rail or overhead line, it's very, very expensive, and it can be up to half the cost of the whole system. If we eliminate this, there's 2 major impediments that go straight away when considering a new system. The high cost of the infrastructure is removed, both in terms of initial cost and maintenance. And any public resistance to ugly, horrible overhead lines, that goes as well. Complete systems can be delivered for under £10 million a kilometre, including the vehicles, and hydrogen generation kits and storage facilities, by the way. Vehicles can be supplied in kit form for local assembly. I won't dwell too much on the propulsion system, but you can see it there on the slide. The trams are totally self-sufficient for a 20-hour operational cycle. And I think it's worth noting that rubber-tired systems, whereas they might be great electrically, they do produce hazards still, tailpipe pollution, brake dust and so on, otherwise known as the Oslo effect. So they are still polluting. The mass of these vehicles is typically under 1 ton a metre. That's with all fluids on board and ready to go. An embedded track will structurally improve the road surface for the future. We don't just specialise in lightweight, light cost systems. We also are involved in conventional light rail tram systems. Here's some examples that we've recently completed. We're active around the globe. In the UK, we're currently working on the Talbot Road extension in Blackpool, but we're held up a little bit. But it shows that we're trying to get a foothold here in the UK and develop the business. So we really do believe that the emergence of light rail systems is still on an upwards curve, with an absolute desire to move towards self-powered, low weight, low cost trams. The Msheireb system in Doha that I've tried to show you demonstrates how they can be integrated into larger transport systems, be absolutely affordable, environmentally sustainable, and aesthetically pleasing. Please don't hesitate to get in touch if you would like any more information. We would be very happy to help. Thank you very much.
Thank you, David. Thank you very much indeed. So I think if you don't mind, we'll move straight into the Q&A and bring questions for you along with the other panelists. So if I could invite James, Stuart and Maxime to rejoin us if they want to put their cameras on and unmute themselves. Right, picking up a few questions then. We'll for a moment we'll work from the end. So a question for you, David. How do the electronically coupled systems actually communicate with one another, if you're able to share? So how does that work?
It's all through closed circuit systems within the trams themselves. It's all electronically controlled. Trams can be virtually coupled and uncoupled literally at the push of a button. I'm happy to provide more detail or ask people to go to www.tig-m.com, where there's a complete section that discusses virtual coupling.
Okay, thank you. Maybe you could put that in the chat then. That would be very helpful.
Sure.
Okay, thanks. So right, sorry, I'm just picking up my questions next. So to James. James, you've got a few questions actually. Is there one you'd particularly like to pick up? Because I think you've had a chance to read them, or would you like me to
yeah, any happy to answer any of them, throw them at me.
Okay, well the big question really is UK PLC. We, as you alluded to, you spent most of this year trying to get the money to keep running light rail systems. So how much weight are you putting on the value of the innovations that you're pursuing in order to help that build back better agenda?
Yeah, we've been doing a lot of work before we even had the pandemic about how the impact of the cost of how we can bring this down. Because one of the challenges government set to us back in 2011 was, to prove that light rail will bring down the cost of light rail, which has been done. It's just that you get these big news stories where people like to do the headline grabbing, big money figures. They seem to miss when stuff comes in under budget and on time or ahead of schedule. They like the ones that run late and go over budget. So there's nothing like a bad news story to hit the headlines. But we are very much focusing on, government have been very clear with us and said, there's an opportunity here. There's not going to be loads of money, but there is an opportunity here that, if the right savings can be made and there's shovel-ready schemes to go, then, they are willing to be, to sort of put the money where their mouth is, really, in that respect. So it really excites me when you see some of these other projects that are being pushed forward and thinking where they can work and where they can go, because it's I've had many conversations with people about we need to start proving the very light rail aspect. We know LRT works in its place, and there's a few big cities left in the UK that can cope with or need a light rail full-on tram system, but there's a lot of places that could do with a smaller light rail system. So some real opportunities coming up.
Okay, so there's some opportunities there for the things we're going to be hearing about later this week, and also for the kind of project that David was talking about.
Absolutely.
So Stuart, are you able to give a comparison between, you talked about 17% for a driver operated system. Do you have any views as to what you would save on an ATO system, or would ATO effectively be modeling that a well-designed ATO would be implementing your system? Is that how it would work?
That's a really interesting question, and something we've looked at. I think with ATO systems, there's no guarantee when they first are set up that they are actually optimized, and that's what we found is some ATO doesn't give an optimized set of instructions to the train or tram to move through the system. So the relative saving depends on how kind of badly that's set up in the first place, and often, particularly for new railways, that when they're trying to get them implemented, that might not be at the forefront of the mind. So I think this technology is really quite useful for applying to railways that have recently been set up with ATO, and then we can come along maybe after a year or so of operation and have a look at how well their ATO is working. And we've seen similar kind of savings, 10 to 20% savings on different station to station run times with ATO. But once you've implemented it, then there's diminishing returns. You can't, once you've got the optimized one or close to it, you can't really improve on it much more without like a technological change. So the idea behind this is it's really simple technology, and getting the railway to run correctly once you've built it and set it up.
Yeah, so you could have had an ATO system that was optimized for timing rather than optimized for energy, for instance. You're making a different trade-off. Yeah,
exactly. And what we find is the most energy efficient way of running a vehicle is through coasting. So it's better to kind of motor hard and then go into complete coasting rather than like maintain a cruising speed, because when most modern traction systems completely shut off and you don't have any losses in the inverters once the vehicle is in coast mode. So it's better to do that than to maintain a steady speed. I mean, what we found is that this was understood hundreds of years ago, but to some extent has been lost in modern railway systems, and we're reintroducing kind of quite elegant ideas into modern railway systems and trans systems, and getting the savings that we know we can get.
Okay, thank you. Maxime, a couple of questions for you here. So there's one about the multi-conductor engine model. So it needs more parameters to be input. So Malcolm Dubell, who's asking the question, I assume that the accuracy of these inputs is critical for the accuracy of the output. In practice, how much more accurate do you feel it is than your traditional MCE model? So you've obviously implemented a new model. I suppose the question is, if the input assumptions are not are variable, then the output must be variable. So any thoughts on that?
Yeah, of course. I mean, the any simulation software has a obviously the inputs will be the outputs will be only as good as the inputs. In terms of difference of precision, the main difference between our two solvers is the first one was not using multi-conductor theory, whereas the new one is. So for certain AC systems, the difference is is significant, especially when we're talking about AT systems. And there's other very important applications which we are focusing on, such as I said, the resonance study aspect, which is quite critical, and identification of harmonics. And we're also hoping in the future to be able to simulate the impact of adjacent high voltage power lines, such as your 400 kV power lines, which may be running in parallel to your train, to your railway, and which may impact the railway itself. So there's many different applications, and it really opens new doors for us. That's one of the main focus.
Okay, thank you for that. David, a question here for you is, and I think this is referring to the Doha system that you showed us. So are the trams and solutions that you showed fully certified under UK regs? If not, what do you think would be needed? And there's another question here. How do you achieve the quoted cost for the infrastructure? So I'm guessing this is all about a question. Could you do it, if you've done it in Doha, could you do it in the UK?
Well, the simple way to answer that question is I don't want to be commercially insensitive at all, but if we were asked to install a system anywhere in the UK, even in the centre of London, dare I say, and we would be rewarded with the same contract value as we benefited from in Doha, we would be very, very pleased and very comfortable. We use local labour as much as we can, and of course costs will fluctuate from country to country, city to city. But with a whole system solution, we know that this can be provided at a cost of between £5 to £10 million per kilometre. Now that doesn't necessarily include all of the civil pre-work, and it depends on how much needs to be done in terms of structures and conditions of roads and so on. In terms of is it fully certified for the UK, I'm afraid I don't know at the moment. I'd have to speak with TIG about that, but I know there are some ongoing discussions with several potential cities and authorities in the UK that are very interested in this type of system. But no, at the moment, no, I don't think it's fully certified.
Okay, thank you very much for that. So James, so I've got a question here about where's it gone? So how, I think you've partially answered this by putting in the link to the UKTram's website, but you mentioned a lot of innovations that are going on. How can colleagues on the call find out more about those? For example, you mentioned resi glaze and switchless points, and are there people looking to implement SciMove or You're muted, I think, James, perhaps?
Yeah, sorry. Yeah, it was a bit slow responding. You click it and I was a bit too quick off the mark. Yeah, SciMove, quick one on that. It's currently being trialled in Manchester. We're compiling a report for members to be able to then look at the benefits that SciMove can bring, and also where they go. There will be a standard that comes out from LRSSB on the implementation of systems like SciMove and the PPOS system. I do think that we'll see some in the UK fit SciMove or a similar sort of system. There are other products of the same type available. before we start getting told off for pushing one in particular, but that sort of device. So yes, like to see something like that in this country fairly soon. In terms of other information, there are some that we've signed NDAs with, so we're limited on what we can give information-wise, a bit like what Elaine was saying earlier on. But if you do email us any ones that we can share information on, there's new stories on the Resi Glass one on our website. So you can follow the links to that, and that will take you to where that one is. That successfully got some funding from a recent Innovate UK grant, so that one's been pushed forward.
Okay, thanks. And if I can stay with you there's another question here, which you showed the bow tie method, which, as you say, has been used in other places, including Network Rail have used it. And the question is about whether or not you know whether you've come across any causation links, this thing that stop a hazard becoming worse than a problem.
Yeah.
That haven't been identified by others, so is there anything that you've found that has been unique to trams, compared to what's been pulled up by London Underground on light rail, RSSB or the HMRI?
No, there's not been anything that's shocked us in what's come out. What has become clear is sometimes there's actually too many barriers that you don't need. There's stuff that's being put in that is actually overcomplicating systems, and actually they're not having the impact that they possibly are intended to. So it's actually simplifying some of the systems, and we're currently working through the top 10 risks that came out of the risk model, running them through the bow tie method. So it'll be really interesting to see what comes out of that in more detail. But there's been no real showstoppers. We've got but more the other way, and that actually sometimes there's almost sort of steps in and barriers in for the sake of having barriers, and it's not actually making the systems any safer, just complicating things.
Okay, thank you. So just before I move on to another question, could I ask my colleagues if they could put the link in the chat for the Zoom meeting, which we're going to move to presently? So I'll look out for well, if we can all look out for that. So David, you're working on Blackpool Tram. You mentioned you said there'd been some issues there. Is that to do with the coronavirus situation, or is it?
Well, no, not specifically. Coronavirus hasn't helped, of course, but for anybody familiar with Blackpool, and specifically at the end of Talbot Road, near the very big Tesco superstore, there was a very large Wilkinson's store, which had to be demolished because that's where the new line, the terminus for the new line, is being positioned. Unfortunately, there were some red tape, land take issues associated with the acquisition of the building itself. And then once that was sorted out, of course, it was riddled with asbestos. So that delayed the demolition somewhat. And then, of course, COVID played its part as well. So it's not entirely down to COVID, I can't say that, but COVID certainly has added to the delay.
So the common story about the difficulty of getting access to site, really. And if I can, a sort of tangentially related question. So you showed the, I think in one of the photographs, it showed the track system waiting to be embedded in the paving, and in your Doha scenario, presumably you were building on a green or brownfield site, whereas one of the things that's often cited as a problem in the UK is when we're going through existing streets and there's all the street works to be considered and all the buried services and so forth. What's your position on that? Do you intend to sort of clear the routes before you move all the services, or do you have a different approach?
No, you're absolutely right, David. Doha was relatively straightforward because it's a relatively new city anyway, and the concept for this Tram was introduced years and years ago. I mean, that said, we still had we still caused a certain amount of disruption to ongoing day-to-day traffic, of course, and some services had to be diverted. Regrettably, that's part and parcel of the project, and if you're going to take what I would call the benefit of having an existing alignment, i.e. A road that's already there, that's an evil that we just have to deal with. There's always an element of having to reinforce on occasion the structure of the road anyway, so we incorporate that with any service diversions that are required. But I think the other thing that's probably noteworthy at this point is that these are very light trams, so the depth of the excavation, it's really quite shallow compared with even a more traditional light rail system, such as in Manchester, for example.
Okay, thank you. I'm conscious it's 3:30 now, and the plan would be to move now over to a Zoom networking opportunity. So in the chat, you should see that there is a link. Don't press it yet, but copy and paste it, I suggest, or copy it rather, so that I'm going to draw this meeting to a close now and ask for the panelists if they would be kind enough to join us in the Zoom networking session. There's a few more questions I could ask, but I think if we ask those in the Zoom session, that'll give attendees more chance to ask questions directly. So can I take the opportunity to thank all our speakers, Elaine, James, Stuart, Maxime, and David. All generated a lot of interest, judging by the Q&A. Tomorrow we continue our theme. So if it's been focused on lightweight, well, the whole week's focused on lightweight and low-cost rail. We've been talking today about tram systems, and we're going to move on tomorrow to talk about tram train and light rail. So there's a couple of questions about tram train, which perhaps we'll pick up tomorrow. So thank you to all the speakers. I'll give you a second to copy the, click on the link, then if my colleagues want to count to 10 and close down the main meeting, I'm opening up the Zoom meeting now. Okay, yeah, there's a load of people in the Zoom meeting, so if those on the call want to join us, that'd be excellent. Okay. Right,
I'm here, David, but I can't seem to get the video working, I'm afraid.